Hello, welcome to the first video tutorial in the series, Essential Skills in Modeling, Rendering, and Animation. I'm your author and video guide, Nicholas B. Zeman. I'll be showing you a few things today in our first introduction to manipulating objects in 3D space and understanding the grid. Alright, so first of all, let's look here. We're using Maya software, and there's all kinds of tutorials that can show you how to successfully use this software and all the tools. And if you follow along with me, you'll see that all of my keystrokes should be recorded here, so you'll get a sense of what's going on, and if I use any shortcuts or hotkeys, you should be able to see them on the screen here. Alright, so let's just go on a really abbreviated tour of our interface here. The first thing you'll see on this left-hand corner is the select, move, or translate, rotate, and scale. Those are our primary transforms, what we'll be focusing on today. Now the hotkeys for these are Q for select, W for translate, E for rotate, and R for scale. And you can see what's happening over here. This is your tool options, and we'll go over these in a second. All of our basic local object and world space coordinate systems and how they vastly differ from one another in the results. Alright, now let's also look at our perspective view. Now this is a perspective view because it contains parallax, which is the converging lines, and what we're seeing here is our grid. Our X, which is horizontal, and you can see the cardinal directions down on the lower left hand here, there's a pivot. So our X is horizontal space, our Y is up and down, and you'll see the Z is coming forward or towards us. This is called a Y-up world. Now I like to see the world as a chess or checkerboard laid out in front of me with the X, positive X to the right. Up is your positive Y, which should always be positive Y is up. And forward and back. Forward is your positive V space, back is your negative Z space. So you can see this like the hands on a clock. The X and Y should read 3 o'clock if the X were the hour hand and the Y were the minute hand. Alright, so now let's begin by creating an object. Now, one of the things I also wanted to show you before I do that is that this is not the only view we can have. Over here, I'm going to change my viewport. These are what we call orthographic views that lack the perspective and lack parallax. So when you want to do something more precise or constrain your object in 2 axes instead of having all 3 axes, you can use one of these more engineering style or precise interfaces. I, however, prefer to see the world as a chessboard laid out in front of me, and the perspective that you have is kind of like a God perspective in which you can look down on your creation and manipulate things in a much larger sense. However, a lot of times you'll need to constrain objects in one area or transform them in only from the top-down view. Alright, so let's get started. Our goal today is to build a simple staircase. And in doing so, we're going to learn a few things about transforms and objects and snapping to points and offsetting our objects and aligning them to one another based on certain points that we call pivot points. So I'm going to create polygon primitive here. I'm going to create a cube. So here I'm just going to I drag out my width and my depth, and then I drag up or down my height. And it's an interactive tool. Now you'll see, first of all, that it has this point here. And what is this point with the little arrow sticking out of it? Okay, this is what we call a manipulator in Maya. The manipulator allows you to translate, and I'm constraining it. The little arrows constrain this to an axis. So I just move it in the X, just in the Z, or just in the Y. Now if I choose the middle and move it around, it will move this in 3 dimensions, but it will move this on the plane of the camera. So the camera has a flat plane that it's showing us now, and this will manipulate this object in 3 axes, but only along the plane of the camera. Generally speaking, we try to be a little more precise and only move it in one direction at once. It's way easier. Okay, now over here we have what's called our channel box. And that channel box contains our translate, rotate, and scales. The scales will always start out at 100% scale, because it's based on percentage, not particular values. Now, scales basically change the space. The thing about scale and rotate is that they don't really change the position of the object itself. They change the amount of space in between the sub-objects, which are known as the vertices. So I'm scaling uniformly here. All I'm doing is changing the amount of space total between these points. So I'm creating more or less space depending on what my scale is. Now with the rotation here, I'm going to choose my rotate. And I'm not really changing, now I'm not changing the space between these, but I'm changing the positions of all of my sub-objects. So like that point is in a different position than there. And they're all changing with the same relative distance from one another. Now, this is what we end up talking about when we mean global and local space. There's a lot of stuff about local coordinates and global coordinates, and it takes a while to really understand the difference between them. I'm going to try to do it in a very abbreviated manner, but you can also read about them in the book. But what's happening is these points in space are changing in relationship to the world while maintaining their relationship to one another exactly the same. So they're all moving together at the same rate in the same amount, but they're changing their positions in space, and that's what a rotate is. Once again, the scale, they all change their positions relative to one another, but exponentially, we're increasing or decreasing that amount of space. Okay, and now, you never want to put 0 in the scale because that means 0% size. Okay, now they're all changing their position, or the amount of space between them, based on this point in space. And this point in space is known as a pivot. And every object has a pivot. And that pivot determines where all these changes occur from. And the pivot is key to this exercise because we really want to know how to get our spaces between one object and another aligned. How do we align things? And how do we create a spatial awareness from different points? So how does this object get to change its alignment or point from which it is moving or rotating or scaling? Okay, first of all, let's just look at our axis settings here. All right, what do these mean? Object, local, and world. And these are the only things we really need to be concerned about. With normals, that's a little advanced. So right now we have object, local, and world. And these all seem kind of mysterious or confusing. So let's first look at our world. World is the most important. The world coordinates down here. Here is the alignment of world coordinates. That is absolute. It never changes. So here is what our pivot point looks like when it is aligned to world space. Now, local space is what we consider the alignment of the parent. In the case for everything we're doing in this particular volume of knowledge, we're not going to be using what's called parenting, which means that an object gets its translations from another object, which in turn gets them from the world. All right, so we're going to completely forget about local. Local basically means whatever it's parented to, and all of our objects are parented to the world. So if we don't parent anything else, it will inherit the world transforms, so that local and world are essentially the exact same. And what these over here are local transforms. What you're seeing here are local translates, local rotates, and local scales. Now, if this object is not parented to anything, that means that these will reflect the world. Which means if I move this back in the Z, you'll see that it's going backwards from the primary view, the primary cardinal directions here, and that means the Z will have a negative value. So it is measuring where this point, which is our object pivot point, is from this point in space, which is the world origin. So of course, if I type in 0 here, I would expect, and I'm going to go to my wireframe mode here, for this point to be exactly in the world origin. And that's where it should be if all of these translates are at 0, and the object is not parented to anything. Okay, so world space, local space, essentially the same for this particular exercise, and both of them derive their coordinates from this origin point in the world. Now, what is object space? Okay, so this is a little bit different. Now, right now, the object and the world are completely aligned. So the object space and the world space are exactly the same. But if I rotate my object here, now those are not aligned. Now we can look at the world axis, and this is just giving me, we'll do this in the translate to make a little more sense. Okay, here's the world axis, right? I move this object in the negative z, and it moves back away from the primary camera view. Okay, seems right. But what if I choose my object axis? Oh, now look how different that is. Because I rotated my object, and its transforms have now changed relative to the world. So the world axis looks like that, but the object looks like this because I've rotated it in the y. And now if I want to move it in the z, look at the difference, moving it in the z. But we also have to look here, the local, it's actually when I'm moving it in the z, based on the manipulator here, it's really moving it in the x and the z. Why is that? Because this is not reflecting object directions, or translates, this is reflecting the local, which is based on the world. I know that could be confusing, and if you're just learning 3D, you might spend the next 5 years really getting your head around local versus object versus world, and it only gets more complex. But eventually you get used to thinking a certain way and understanding that when I'm moving this based on the object's pivot, I'm actually not moving it, it's not offsetting it from the local coordinates, it's doing it based on the world coordinates. So there's the z of the object space, and this actually, I misspoke, this is the local, and this is the object. Okay, so now let's just zero that sucker out. All right, now that we've gone through all of that, let's go through a couple things about our control and how we can adjust the point at which all of this stuff is being calculated, which is that pivot. And we have something called pivot mode. Now, because my goal here is to make a staircase, and I'm just going to make a simple staircase, and I'm going to do it over here in this right-hand quadrant, so I'm just going to move this guy over a little bit, just so he lines up in the right-hand quadrant. All right, now the problem is this pivot point is in the center of my object. It's not very useful for aligning things. If I want to make a staircase, and it's going to make this is the base of the staircase, I want it to align with the ground plane, which is 0y. And in order to do that, sure, I can kind of make it move up a little bit, and I can kind of eyeball it and say, well, it's close here. And then maybe I can scale it to make this a little smaller. But you see, everything's happening from this middle point, which is not really very useful for me. It's really hard to get this to set up right, and then I want to scale it some more, and I'm like, well, now it's scaling it from the middle point. It's not very handy or useful. So what I want to do is change where this pivot is. So we're going to learn two things right now. We're going to learn how to move into pivot mode. Now I'm using a Mac, which means I have a Mac keyboard, or Apple keyboard, and the pivot mode shortcut for this is function left arrow. Now you see what happens? It changes to pivot mode. Now I can move the pivot of this object anywhere I want. And I'm just going to arbitrarily stick it over here, because this will be the most dramatic change. Now what does that mean? I've moved the pivot. Well, I'm just going to get out of pivot mode. If you're using a PC, by the way, the insert key is the function left arrow key. Or it's really the other way around. Function left arrow is equivalent of insert on a PC keyboard. So if you're following me on a PC, this will be insert, not function left arrow, which toggles you back and forth between the pivot mode. All right, so now that I've moved my pivot over here, what does that really mean? Well, it means that all the equations for the scale and the rotate and the translate are all going to happen from this point. So if I want to scale it, you see how it's not really scaling it from the center of the object anymore. It's scaling it from the pivot, which is way over here. The same goes for rotate. Now I get some kind of bizarre, crazy rotation because it's happening around that point in space. So that's what happens when you move the pivot point. It dramatically changes the way your object behaves when you use your basic transforms. So let's just put this back to where we want it to go. Okay, so now how do I get my pivot point to a place that is even moderately useful to me in terms of creating the object I want to create? Alright, I'm just going to move this up so we can see this a little bit better. What I really want to do is I want to put this pivot exactly at that point. And that point is called a vertex. It's the point in which the lines, which are called edges here, converge. So how do I get this and make sure, and I can go to my function left arrow or my insert, which takes me to pivot mode, and I can try to line this up, but you know how long and hard this would be to perfectly line this up. It's really hard to see all the coordinate spaces, and you never quite get it exactly on the point where you want to create. You can see how long it's taking, because every time I move, you see it looks kind of like I've lined it up, but when I move the perspective view around my camera, it's completely off. And it would probably take me an hour of slowly doing. Trust me, when I first started doing 3D, this is the kind of thing I would do in order to line things up like this. All right, we don't need to do any of that. That's ridiculous. What we're going to use is what's called a snap. And a snap will snap this to any type of point or point in space of our choosing. In this case, we are going to hold the V key down. The V key down is a snap to a vertex or any point in space that is defined. So now all I have to do is click and drag and boom. Now it'll snap to any of these points. And let go. Now we leave our function left arrow or insert, which is our pivot mode. And we can see that we have a point in space where we snapped this that's actually useful now. Why is it useful? Because now I can use my next snap tool I'm going to show you, which is the X key. That is the grid snap. So it'll snap to any point along this grid. And now I have the bottom of this perfectly aligned. Why? Because I'm moving it, snapping it to the grid. And you can see it'll just basically snap and stick to that point. And we know that these are perfectly lined up, this corner and this grid, which means that my entire face on the bottom here is perfectly aligned to the bottom of the grid. Now, it's very useful for scaling, right? Because now I can scale it from the bottom. I don't have to keep readjusting the position. And I can scale this backwards from this point in space. Now what I'm going to do here is I'm going to move this pivot point back a little bit. And the reason I'm moving it back is because I'm going to build a staircase, and we're going to keep iterating these stairs going up and up based on this point in space back here. So once again, I'm going to hit function left arrow, hold my V key down, and we'll just snap it to the rear left, and then get out of our pivot mode. Now why are we doing this? Because I'll show you why. Now I'm going to go to Edit and Duplicate. Now, by doing that, I have created two objects. Let's just lift this object up here. So we've got the exact same object, but we have a copy of it. And now I can hold my V key down and snap my object to this object vertex, which means these two objects are perfectly aligned. They are identical, and this one is perfectly stacked on top of the other one. And now, if I want to create a second stair, I can simply scale it back in my Z-axis. And now you can see, when we continue to iterate this up, that it will form a staircase. Now, one thing that I'm not doing properly yet is that you notice these values. If I want to create a consistent change in the Z scale here, I have to do a lot of weird calculations. Well, because this thing is not perfect in terms of, once I've laid it out, it has all these weird translations, 115.774 or 744. These are all very arbitrary and strange. I mean, because they're all calculating the distance from our world origin here. So what I want to do, I'm just going to delete that. What I want to do is make sure that these are all reset to something easier to work with, but not changing the position of this object at all, or the scale or anything. So what I'm going to do is go to Modify, Freeze Transformations, and let's just make sure we've got Translate, Rotate, and Scale, and never mind about this normals here, and just click on Freeze Transforms. And you'll notice now I've got 0, 0, 0, rotates are 0, which were 0 before, and the scales are 1. So this makes life so much easier to deal with, right? Because I need to change these and iterate through these duplicates so I can make a staircase. I want it to be 0. Now, what I can do is just duplicate this here and hold my V key down. And we can see that the exact distance between this point and this point is whatever our offset in Y is. So now we have a really simple way to tell what's the offset, 12.904. I'm just going to copy that. And now I can change my scale of Z to 0.9, which will peel back the first layer of stairs. And now I can duplicate, transform. Remember, I'm snapping again, so make sure we're exactly right. And change my scale of Z to 0.8. And you can see how this is going to go. I'm going to create it again. And every time I go up, I'm going to change the scale of Z by -0.1. And there you have a staircase, perfectly aligned. 1, 2, 3, 4, 5, 6 stairs. Now, could I have done this a little faster? Yes. Well, I'm just going to duplicate this so I can show you another technique in building complex pieces like this. I'm just going to offset this a little bit. Now, let's go to Edit, Duplicate with Transform. We never want to do more work than we have to, or duplicate special. So now we can say our translate. Remember I copied that value? Alright, so every time I translate by 12.9040, it's going to stack this object right on top of this object in the Y. Right? So this is X, Y, and Z. Now we don't need to rotate it, but our scale for each one should be 0.9. So basically we're going to scale that by 0.9 every time. Now that's going to give a slightly different result because it's not going to scale it by -0.1 every time. It's going to scale it by 0.9. So we're going to get 90% of each one, so it's going to probably be exponential and in a decreasing manner. So I've got this number of copies, 8. Let's just hit apply and boom. Now you see I created a staircase a lot faster, but what I was saying was that every time it scales this, right, this one will be 0.9, but it will scale 0.9 by 0.9. You see, so it takes 0.09 out of it. And you can see it's exponentially decreasing in the amount that it scales it. Why? Because you didn't freeze the transform every time. Because it's taking 90% of 90%, which is 0.81. So it's not exactly the same, but it's a way to automatically iterate creating a staircase. Now there is actually a way to do that, and that's resetting. Every time you duplicate it, and you'd have to write a script for this, you could reset the scale to 1, which would then come up with the exact same results here. So everything is able to be simplified and recreated. If you have to do the same thing over and over again, there's a way to do it a lot faster and automated in 3D. Alright, so what have we learned? We've learned a little bit about the grid, about the world origin. We've learned how to move objects, how to rotate them, and how to scale them. We've learned how to change our pivots, and we've learned how to snap those pivots or anything, any object, to other objects' points, or to the grid using the X key. And we've also learned how to freeze transforms. So to take some very strange transforms offset from that world origin and turn them into simpler transform values, which are 0s and 1s, that we can offset from. And we've also learned how to create or duplicate an object with transform offsets in an iterative way. So this ends the first lesson in Essential Skills in Modeling, Rendering, and Animation. I hope you learned something. You can follow along with this in the book exercise step by step. And you can also check out exercise 2, in which we're going to build a staircase in a much different but more efficient manner.